Hello everyone. Now we'll be starting off with a few numericals. Basically, we'll be trying to check it out what pattern type of questions are being asked for generating a particular string by using context by using grammar. Now, don't get confused. We are dealing with few examples for regular grammar. Then we will check it out with the after completion of the numericals. We will check it out how to how to identify a particular context-free grammar or a regular grammar. Okay. Before starting off with the context-free grammar, I want to deal with the topics like how to generate a particular string, how to generate a language based on the grammar. Okay, then how to verify whether a particular string is being generated by a grammar or not. So these three pattern questions we will discuss. So the first pattern question is this one, where I have to generate a string from the grammar given below. And then second pattern, I will let you know whether we have to generate a particular language from the grammar given below. So let's start off with the first solution of the first question. So where they have asked to generate a string for the grammar G. Okay, now the grammar is given to you with only the productions. Productions means of the form alpha tends to beta, correct? Now let me write down the grammar for this. Okay, now if a grammar format of grammar is G is equals to V T S N P. This is the format, right? Now here V means set of non-terminals. Again, I'm repeating to identify easily or to memorize easily. Set of non-terminals are those which are capital letters, correct? So here capital letters are S, A, then okay, fine. Only these two, right? Therefore, I can write down as for this one V will be S and only A, correct? Now, apart from these capital letters, others will be your terminal symbols, that is T. So here terminal symbols are small letter A, small letter B, and one more is there. Don't get confused, epsilon. Okay. Other than capital letters, other than non-terminals, everyone is your terminal. So the terminal symbols will be small letter A, then small letter B, and epsilon. Correct. Okay, now start symbol. Start symbol, as I've told you, with the going with the production rules, the first alpha tends to beta will be your the alpha will be your start symbol. So S will be your start symbol, and P already I have told you that these are the productions. So grammar I have defined. Now I have to generate a particular string. The same way, what I have to take? Step one, you have to take the first production. The first production starting with the start symbol. So S tends to AAB. S tends to AAB. Correct? Now here I have to, my motive is to bring the generate the particular string. That means generate the particular collection of terminal symbols. So I have to eliminate this A. So A I can eliminate with the help of either epsilon. If I put epsilon, then the string will be like this here, since A tends to epsilon, correct? Or then the final string will be what? AB. So this is one particular string. So from a grammar, you came to know that from a grammar, based on the productions, there can be a single string or there can be n number of strings. Okay, now I will try to find out one more possible case. How? I will take again the same start production, correct? S tends to AAB. Now here I have already gone through a second production, that is AA. So AA I can replace by all entire string. So I can replace this entire AA by AAABB, correct? So if I replace A again by suppose epsilon, so what will be the string now? AABB. Clear? Okay, so now I have got two possible strings AABB. Now if I carry on one more time, suppose S tends to AAB. Now if I replace this AA again by the same process AAABB, correct? Again if I replace this one by the production rule, same, then I will be getting A, A, B, and then BB, And if I replace A by epsilon, A, epsilon, P, B, P, therefore the final answer will be A, P, B, P. So it depends how many times you want to find out or what kind of string you want to find out. So if the question comes that you have to find out only generate a string, that means you have to find out any string based on the marks given to you. अगर if the question mark carries suppose 7 marks, then you have to do the steps a little bit better, a little bit longer. Then you can extend this particular scenario and you can take a bigger string. But this type of question generally asks for small marks, only 3 marks or something like that. So you can generate any of the string that you want to do it. So I have given you 3 possible cases. You can get n number of possible cases with this scenario. So this is the first pattern question, right? Now next pattern question, we will look over to this. Now the next pattern question, they are asking generate a language for the grammar G with the productions given below. So the same process, I won't be writing the grammar, but yes, if you want then you can also write it down the grammar. So I'm writing down the grammar, you can pause it and you can also try on your own. So first one will be S, A and B. Then and any other non-terminal symbols? No. Terminal symbols will be small letter A and small letter B. Start symbol is S and P is the productions, correct? Now I have to generate a language. Now keep in mind, when you have to generate a language, you have to find out at least 3 to 4 strings so that you can find out a similarity between all these 3 to 4 strings. Then you have to conclude that you will definitely get a particular format if they are asking for generating a language. So based on that format, you have to use your own logic that based on these 3 or 4 strings, what kind of format is based on. Suppose I'm taking this example, I will try to extract in the same manner. Now, if we go with the previous one, if we ask for the previous one, there I have find out one is AB, then double A, double B, then triple A, triple B. If your logic applies for the fourth one, we can also get 4 times A, 4 times B. Then what will be the language for that? That means A to the power n, B to the power n. Correct? So the language will be like this. So if you want to find out for this, what will be the language? You can also try it and you'll be getting the answer as A to the power m, B to the power n. Okay, why? I will let you know. Now suppose let me try with the first one, that is S tends to AB. Okay, now if I replace A by suppose the first production of this one, then A and then B. If I replace this by again the same production A, B, correct? So here I can write it down since A tends to AA. Here also I write it down since A tends to AA. Okay. Now if I replace this A by small letter A, then the string will be like this, correct? Here I can write it down since A tends to small letter A. Okay. Now if I replace B by suppose small letter B, then A, B, correct? This I can write it down as small letter B tends to small letter capital letter B tends to small letter B. So this is one string that I have find out. Okay, I will take one more string. Suppose I'm taking S tends to AB, and I am replacing direct A by small letter A, and I am replacing direct B by small letter B. Okay, so one more possible string I got it, correct? Again I will try one more condition, S tends to AB. Now here I will replace A by small letter A and B by B as it is. Now in terms of B, I will replace with the first production of capital letter B, like this, B, B. Again I will replace B by again same production, first production. Okay, then it will be B, B. And in terms of B, capital letter B, I will replace only by small letter B. So what kind of strings you are getting? You are getting a format like, therefore the strings that you are getting are basically, I have concentrated only on 3 strings, that is AB, triple AB and A triple B, correct? So you can also try n number of times. Then the number of A and number of B will never be equal. Only in the first case. If suppose A to the power m and B to the power n is the language I am finding out, then m and n will be equal only for one case, that is A number 1. That means A, B. Otherwise, everywhere m and n values will be different. So finally, I can write down the language as A to the power m, B to the power n. And here I can write down, since powers are different. That's it. So this is the only process of finding out a language. So for this particular scenario, you have to find out at least 2 to 3 strings, and based on those 3 to 4 strings at least, and based on that you have to find out a format or similarity between those strings, and then you can find out the language. And then similarly, if I talk about the first one, the language will be, as I told you, A to the power n, B to the power n. But here only they have asked to find out, to generate a particular string. Got it? So these two patterns are very important for generation of a particular string or derivation of a particular string from a context-free grammar. Now, this is your second pattern. Now let us go with the third pattern, where you have to verify whether a grammar is generating a string or not. That means a string will be given to you, and you have to verify whether that particular grammar is generating or not. For that, I'm taking an example. Suppose this one. Here I have already mentioned you the method to find out whether a string belongs to a grammar or not. So I won't be writing these things. You can pause the video and you can check it out, or you can note down the steps. Now I will take one example directly, and we will try to find out whether this particular grammar is generating that string or not. See, the question is given to you, the grammar is given to you, and we have to find out whether this string is generated by this grammar or not. So, and one more thing, don't get confused with this particular symbol. This is nothing but the epsilon only. Okay, in some books they used to mention like this, and but in maximum of the questions they will ask you as epsilon only. Okay, null symbol. Now they have how do we have to find out? We have to find out a pattern for this. See, what they have taken, the string is starting with 0. So definitely I have to go with the start production, which is having 0 with the right in the right hand side. So right hand side is having this production as 0. So I have taken the first production as S tends to 0b. Then I have seen that again after 0, again one more 0 is coming. Definitely this 0 is fixed. So again, in place of B, I have to find out a production which is having 0 as in the right hand side. So for B, if I went to B, then B I am having this production as 0BB. So in terms of B, I will replace by 0BB. That means first two string has been confirmed. Then I have to check whether in terms of B, the next string is 1. So similarly, B, I'm having the first production and the right hand side as 1. So in terms of B, I will replace by 1. See, you can check it out in every steps I have mentioned which productions I'm using. So this is very much mandatory while writing in your examination to mention which production you are using for simplifying. Please make it sure. Okay, now same way I have to do, this is your logic. This is how you are applying your logic. But my main funda is that you have to check the string first, and you have to generate and you have to use these productions based on the string. So 0 is the first one, so definitely I will take the first production. Again 0, then I have to check then for B, which is having the 0 1, and similarly way. So finding out this, you will get the string, and you have to mention all the productions. Therefore, we can finally say that using the above grammar, the string this one has been generated. So this is already I have done the example for your benefit, and you can pause the video and you can note down these particular numericals. Okay. Now, last topic that I want to deal with this in this particular video is that these are the 3 pattern questions. Now we will be discussing only one thing: how this particular derivation process can be done with the help of a data structure, that is derivation tree. Okay. Now this derivation tree is very, very important from your exam point of view, as because In generally next year you will be studying a topic, subject name is compiler design, where you have to design a compiler. For designing a compiler, the basic knowledge that you require is your derivation or parse tree. Okay, so we will check out how to work on this particular topic, and here I will let you know how to use the concept of parse tree, and I will let you know how to convert a particular grammar into a parse tree, and then with the help of parse tree, how you can generate a particular string. Okay, so let us check it out with the with an example. Okay, so I'm bringing out with a small definition part, but derivation part I will let you know. I will explain with an example. So if you pause the video and you can check the definition, a derivation tree or parse tree is an ordered rooted tree that graphically represents the semantic information of strings derived from a context-free grammar. So the main meaning of this is that the parse tree is nothing but the ordered rooted tree where there will be a root vertex, where will be the child vertex, and from that child vertex, with the help of productions, you will be able to find out the terminal symbols, and that is the main concept behind derivation tree. So I will take an example which I have already taken earlier. Okay, and the example that I'm going to take is this one, where they have mentioned the grammar VTPS and they have mentioned the productions over here. So I will try to write down this production, and if I write down this production, production is given to you as S tends to 0b, A tends to 1AA slash epsilon, and one more is there, B tends to 0AA. Okay, this is the production given to you. Now you have to derive a string by using derivation tree. How? Always remember, for carrying out or for finding out a derivation tree, you will come across with three different parameters. One is your root vertex. Okay, next one is your vertex, and last one is your leaves. These are the three things that you have to keep in mind. Root vertex is one, you can just listen to it. Root vertex is the one which must be labeled by the start symbol. That means I can directly write down as S, start symbol. Vertex will be labeled by non-terminal symbols. Vertex will be labeled by non-terminal symbols. And finally, leaves. Leaves are labeled by terminal symbols. Just keep in mind these three things, and it will be very easy to find out. Okay, now this is the production given to you. These are the three parameters you need to keep in mind. Now let us check out how to draw the diagram. So as I told you, root vertex is S, so S will be denoted by like a circle. So always remember, only the non-terminal symbols will be represented by, that means the vertex will be represented by a circular shape. Okay. Now from S, I am having this particular production, right? So from S, I can draw 1 0, and the other one is your P. Correct. So what I have to derive? I have to derive a string. So I will draw a small tree only. I won't be drawing a bigger one. So in here, what is the non-terminal symbol now? Non-terminal vertex V, B. I have to replace this B with the production, this one. Correct. So I can draw like this: 0, A, and vertex or leaf vertex or root vertex you have to encircle with a circular shape. Now again, I have to replace this A by, either you can use directly this one or A epsilon. So for first A, I will be using this production, and for the second A, I will be using epsilon. Clear? For first A, I will replace it by 1 A. and for the second A I will be replacing by epsilon. Clear? Again for the first A I will be using the same epsilon, and for the second A I will be using 1 A. Clear? And then finally I will replace this A by epsilon and this A by epsilon. So now you can check it out, all the vertex and root vertex has been eliminated. Now you are getting now how to check the string from left hand side bottom and then right hand side. That means from the left hand side then to the right hand side. So this is the way to find out. So first string will be your 0, second string will be your 0, then third string will be your 1, then fourth string will be your epsilon, then fifth string will be your 1, then epsilon symbol, then epsilon, and then finally epsilon. So epsilon I can eliminate. So then finally the input will be 0, 0, 1, 1. So this is the string that has been derived by using this derivation tree or parse tree. So please you can. So what we have learned in particular this video, we have understood 3 pattern questions where we have understood how to generate a string from a grammar, how to generate a language from a grammar, and finally how to use the concept of derivation tree or parse tree to generate a particular string. Thank you. We will check it out with the next topics in the next video lecture. Thank you.